Luther Kruger, Big Blue Sun Museum of Solar Cooking in Minneapolis, and I'm here with Joe Bradley with the Sun Buckets organization, company, corporation, ready to take over the world for solar cooking. And a very unique project here. I know people that are fiddling with it, but you guys are taking it to the next level, getting it out to the countries that need it. Already posting kind of your early results and learnings as you go along. So I know people are really interested in finding out just what it's all about, but also, I mean, starting out, I always have to know, how did you get into solar energy, solar cooking? When did it all start for you personally?
So working with one of our key founders, Dr. Bruce Litchfield, who has been working on just cooking, more better, sustainable cooking for years. He's a professor emeritus from the University of Illinois. And Sun Buckets is a spin-off from a university-based technology. And so that was kind of the origin of it. And so so it's been a problem he had been working on for many years. And I had known Dr. Litchfield for a number of years. And as he was thinking about they would make better cells that were still using firewood or charcoal, it was like, there has to be a better way, a more sustainable way to attack this. So he started to explore and think through the idea of using thermal, like he's still using sun to charge, but can we actually store that energy and use it and recover it for later use? And so that became probably the impetus for how the project got started. So he started researching the area with one of the other co-founders, Matt Alonzo, working on developing a technology that could store that energy from the sun and also be able to have the same effect of using firewood as in terms of cooking capacity. And so we started thinking about how could we really get this out into the markets, to the most needed communities. I don't know if we thought in terms of a company initially. It was more in terms of how to get this out, and a venture is a good pathway to move technologies and ideas and inventions from a university lab into the marketplace. And so we got engaged in the NSF I-Corps. And so I had some business background. I was working in industry, and I was in the transition to moving into faculty at the University of Illinois, and was invited to say, okay, we're working on this. Let's see if there's a path forward in terms of taking it commercially. So we participated in the NSF I-Corps program to go through their whole customer discovery. So it's a program with a purpose of helping faculty, individuals within the academy to think about how to take their inventions and ideas into the marketplace. And so we started to work on it, and then we got accepted to the NSF I-Corps National Workshop. So we went through this 7-week kind of intensive of understanding the markets. And so we always wanted to target those communities who had scarcity or limited access to energy. And we thought that the ability to do storage was an opportunity to do that.
Sure. People have fiddled with it. But you guys have had university resources to draw on, other outfits helping out too, or how's that working out?
Yeah, so in the early days, a lot of our early funding, so it was non-diluted funding, which is how we are currently. And so we had won some business plan contests. We also got a really significant award from the Humanitarian Grand Challenges out of Canada. And it's a collaboration with many other NGOs and these types of organizations that wants to help in different lower resource communities. And so we've been able to receive funding through those resources. And also one of our first projects was in Haiti for orphanage there, where we made initial, I guess, first sale, you'll say, for using the Sun Bucket. So that we've kind of grown by working primarily with humanitarian organizations, but we also see additional opportunities in disaster preparedness. So those are some of the things we're investigating for future opportunities.
Sure. I caught the video, and I think it was in Haiti, where the test was being done to make sure that people got it and understood the process and how to use the cooker and so forth. So are you still there, or have you branched out, or how is that? Where do you stand now? Yeah, so now we have, I say, a growing presence in Kenya in the refugee camps in Kalabaye and Kakuma. And so we have, we've started Sun Buckets Africa in Kenya office with a staff there that's doing a phenomenal job in terms of really bringing technology to the refugee camps.
where the UN, UNHCR wants to reduce their reliance on, of course, of firewood and kind of climate forcing fuel sources.
Yes.
And so Sun Buckets really, I think, fits right in that gap of where we can have that reduction in those climate forcing based technologies. And so we have a lot of tests going there, and our humanitarian grant, Challenges grant, was actually a part of that initiative to bring more of these buckets into the refugee camps and at least see if there was any efficacy in terms of using this. And we're building out a business model to be able to support the community through a pay-go system, because it's not similar to where you go retail here and we'll buy an appliance. It might be something that's paid over time. So we're instituting different types of business models to be able to be successful in that marketplace. So we're also exploring in India, where we're setting up a Sun Buckets India subsidiary as well, which we're thinking to target the population there that's under-resourced that might use this as an alternative, or in some form of fuel stacking or cooking fuel stacking, sure. Where when you maybe run out of your propane and it's more expensive, if you bought the Sun Bucket and it's a great, lots of sunlight, you can take it outside, and then in 2 hours, between an hour and a half to 2 hours, you have a fully charged bucket. Sure.
Well, I've talked to a lot of organizations, a lot of people that make cookers, and one of the big questions is, do you make it here and ship it there, or do you try to make it there? Can you get the materials there? Sounds like you've landed on, you're going to get the materials in India to do it in India, and Kenya to do it in Kenya, right? You're not making the buckets and shipping there, which would be, I mean, they weigh a ton, right?
Yeah, so they weigh probably about 20 pounds or so. Okay. And so we definitely plan to source from the region and the community that we think the greater utility might be as far as really providing a need. And so we've worked hard, and when we spent time in Kenya, we actually sourced, while we was on, one good example was while we was actually there, we needed an extra part. We was able to actually go to a local foundry and actually built out a part that went on our product. And so we knew that they had the capability to actually build these there. So we're now looking at that being an integral part of the supply chain in terms of building in the community and hopefully providing, workforce development, other things, as opposed to us just bringing a product and trying to sell a product. We're saying, what can we do to the overall community that we're involved in or that we're actually selling products in? So that's a big mantra, I guess you say, or motivation, or one of our core values in terms of as we develop it and bring products to the market.
Sure. I have a slight personal stake in this. I worked for Minneapolis Police Department. I'm a civilian, but I worked with an officer who got a one-year stint with the United Nations in Kenya to investigate the smuggling of charcoal into Somalia. And big problem. I mean, big enough where the United Nations is stepping in and scouring the world. We have a big Somali population in Minneapolis, and so she had built up all sorts of relationships and understood the culture, and so she spent a year there. I actually had her speak to my class at Metro State via Skype from Nairobi. Was that an eye-opener. But so the need is great, and it's recognized. And Solar Cookers International, they've been working with the government in Kenya to get them to really endorse projects that help with solar cooking. And it sounds like they've got some accolades from the United Nations or world. I don't know who they've gotten them from, but they've gotten some certification saying yes, they are really serious about getting solar cooking going. So you picked a winner as far as a location where they're serious about it. And India they've had a pretty long history of developing solar cookers, a lot of parabolics and so forth. So that's really great. So basically there you're able to find what you need to put these together, including, I understand, it's kind of a salt type thing. Storage? Yeah, so
to create that heat, that latent heat that you find that's within the Sun Bucket, we use a phase change material, a combination of different types of salts that go through a phase change. And so it goes from that solid state to that liquid state, and then it with all that remaining, that latent heat, we're able to then recover that for cooking. And sure. So that was one, and so it's that material is I guess you could say it's semi-abundant, but we're able to get access to it in those different regions. So sure. It seems like it's a good component of our supply chain, so we're able to actually supply and provide all the raw materials that we need in order to build in all those regions. We've actually have pilot manufacturing going on in those locations now, just to see if we've been able to actually build them in those places as well through sourcing whatever we need to do from outside the region, but been able to actually do what we had planned. at a hopefully at a lower cost. We're still doing them in low volumes, so we haven't seen what it really looks like to scale to where we will source supplies to make 10,000. We don't know how big that shift or that what will happen in terms of the overall production cost, but that's where we're testing and piloting, and we're with the same humanitarian grant challenge organization. We're also in the process of getting one there to scale grants, which will put more resources into actually scaling and building manufacturing and supply chain efficiencies to make sure that we can deliver the product with the same quality and value that we would expect coming from the U.S. in those same regions, because they have the capabilities and the assets to be able to deliver that for us.
So how do they work? I see a couple versions here.
Okay.
Yeah.
And so what we have, so we've done testing in this location to just test the efficacy. Do they heat up properly, retain heat? Are there any leakages due to the fabrication manufacturing processes, and how we can mitigate any kind of thing that we see that we don't want to send a product into the field. And so basically how it works, this is what we have as a current finished prototype. We've prototyped many different form factors for the product to see which ones might work, and we're even moving forward in a little bit more of the aesthetic design parts in the future to really have that good appliance feel, but also they're sturdy and still have the efficiency and effectiveness that we hope for the product to have. Is a device that we place on a parabolic dish. If you go to our website, you'll see many of these with a sun bucket attached to the top, or kind of dangling, kind of suspended above one of these parabolic dishes. And so we've created a modification to this dish. So you might find these typically on your standard solar cookers. And what we've done is made an adaptation to those devices where the sun bucket sits on top of that. And of course it has this concavity, and so it reflects the sun rays onto the bottom surface of the sun bucket, and it causes that phase change material to take place, which creates the heat. Up to about 650 Fahrenheit, and so they're getting pretty warm, almost at the same temperature as a fire. And the only surface, if you kind of take a look at the sun bucket, what we have is a thermometer to kind of give you a sense of where the temperature, so it's around 300 or so. You can remove it from the parabolic dish. And only this hot front hot top surface is the only thing that gets hot. This is hot as fire. We've cooked, we've even baked bread in a bake pan on it. Sure. So anything that we want to, any type of the forms of cooking, we can create. So that'll be the only hot surface. So after it's done charging, an individual can remove it from the bracket that we've modified for the solar cooker, hold these handles, which should be cool to the touch, and then carry this off into your home or into wherever you decide to cook. And immediately what we have as a part of it is an insulated lid. Place this lid on there, and it'll store this until it's time to cook. And so we've tested it in this around 6 to 7 hours. We still have pretty good heat, and we're still working on a way to give it that type of capacity longer time. But what happens is once you start to cook, of course you're going to start, the energy is going to go into the food to cook it, so you're going to start to lose the heat in the bucket itself. And so we recommend you cook those. Those foods are going to require more heat to prepare initially, and then after that you can kind of sequence out how you would cook. The average size family, maybe from maybe 4 to 8, 4 to 6 people in the family, we probably need about 2 of these buckets. So if they charge 2 of these buckets, we believe that we can definitely cook lunch and dinner. We're still working on a way that we can increase the capacity, maybe give you a little bit of something for breakfast, but right now we're real confident that we can probably do those two meals. The big challenge is how do you seal these components? Yep. And you'll see we have sun buckets. This is kind of proprietary way that we're able to do it. So how do you seal these? Because there's got to be some thermal expansion at different points, and there could be a potential, if this is not properly configured, there could be some kind of thermal linkage between this side and where it get hot here and make the complete vessel hot. So those are some of the challenges from manufacturing, and then even in some cases rigging together and developing the process of filling this is also, because we need to fill at a certain temperature of the salt, because the salt, plus we need to heat it up with that, and then see how much it's going to expand with the salt and seal it. So those are the manufacturing process challenges that we've overcome. Before, it's the outer shell. Outer shell is just taking, there's a lot of work in this area of appliances and using aluminum. So those are things that we could overcome, because there's processes and spinning that allow us to be able to build out outer shell a little bit more easily because there's well-known fabrication process for that. But for making a small form factor heated device is going to have a lot of expansion in a smaller container is where I think we really had the opportunity to have some good technical breakthroughs and opportunities to grow.
The heating element must be kind of like its own little self-contained bucket inside that and then wrapped in insulation, right?
Yes, and that was the way that we approach it. And this could change through other prototypes that we have. But we wanted to have it so that this part, if anything, make it modular and have a combination of a lot of modularity. So if any part could break, we could also maybe potentially sub and change components out. So yeah, you kind of think of, we have a hotted component where all the heat is contained, and external, more of an encapsulated structure that holds that. It has insulation, and it has fins that allow the heat transfer to be successful from the phase change material up to the top surface. And so there's a lot of thermal fluid analysis and thermal analysis that went into that kind of fin design to optimize the flow of the heat to make sure that we're getting good coverage.
Sure.
And I mean, of course, we run into challenges is when we were designing. One thing that was really great by going out into the community and testing it, by spending time in the refugee camps and testing, is that we typically think that when we have like a flat, you think you have flat containers. That's not the reality.
Someone brought a walk into the room, right?
And even just from using the pots and pans over an open flame, has put the suit and all of the different layers on the bottom of the pots. And some of the pots are almost at a point, and so it's not flat surface. So we get complete total heat transfer and more surface area we recover. So we had to think about, okay, how can we still maximize good heat transfer even for pots that have surfaces that are not flat. We also provide new pots and pans as a part of the package, so they have new cookware to work with in order to utilize with our product.
Sure. You know, I'm thinking of one. So the question I have with this is, I collect solar cookers, and I have 8 or 10 parabolics, different ones. The SK14, the Simplicity. I've got a model like that, maybe a little smaller. You got to move these around a little bit to keep them in focus so that thing heats up, right?
Yes.
Do you have anything like I've heard of trackers out there where they have solar panels that make sure it's in focus, or is it pretty much manual still right now, or how's that work?
So right now it's currently manual, but we are exploring the tracker. Our biggest challenge is making sure that price, that cost to that end user, to the community that we'll be selling to, how to manage that. So we've looked at some mechanical-based trackers that's going to operate just through some kind of simple machine type of mechanisms. But we also have those kind of electronic trackers. And we've explored trying to figure out, should we build our own or make some modification to one in the market, and how can we make sure that we can still keep it at a price point, and also, because we know that will increase user the utility, because that was some of the feedback that we have received with them being in the refugee camp, just for that 2-hour kind of block of where you get the most significant charging time, needing to run out there every 15 minutes or so to re-angle and make sure you have the sharp edge point at the base, has been a challenge or something that we know we want to make sure we mitigate for the end user.
But you say in about 2 hours that'll hit 600 Fahrenheit?
Yeah, so about 2 hours, and of course there's some, like today if it was outside, it's very cloudy, and that's one of the challenges with using this. And so, but in the region that we're targeting, they have a greater percentage of times where there's great sunlight, then they have cloud coverage, and so we believe that those are ideal conditions. But there might be a need for some level of cooking energy source stacking, and so, but if you have this, you already at least have one, and when there's sunlight, you have to use your other options, especially if those options are non-renewable, and you have to purchase those each time you use them up, whereas once you buy one of these devices, you have it, and we predicting useful life of at least 10 years, and it can be dropped and fall and different things. We've seen them pretty beat up in practice, and so they're still able to heat and do and perform as we would expect.
So the future, you've got Kenya, you got India, you're kind of lining up some more, maybe a little bit of research, but you're actually starting to do stuff with them. What else is going on?
So we're definitely want to expand the utility of the bucket being able to be charged with parabolic. So we're looking at some opportunities I think in Uganda, and we've been to Somaliland. We've been there and set some up. We don't know if it's going to grow in the Somalia or Somaliland region, but we're working to do that. And so many different countries across Africa, we're looking to see if this is a feasible or a good option. And then extending upon that, what we're looking at is now is charging this using PV sources as well. So and so we haven't completely decided how we wanted to approach the PV technology, but we are researching it and doing options now where we'll place the heating elements within the lid.
Sure.
And so we'll place it on top of it and it'll be able to charge over a period of time and using power source from PV. And so you can just have it through a system that's built within your home. Sure. And set this off in there. This puts on and plugs into whatever your kind of source that you use your PV from. And so we're seeing like an uptick on PV being used across Africa. So we want to make sure we have a technology that can implement with this. So you can either take it outside, charge it in the sun, or you can use it inside as your standard cooking. It will be comparable to your electric stove. And one thing, because we're using thermal storage, we have higher efficiency, I believe, because we're going heat to heat, transfer heat into the food to cook, as opposed to going from electrical to converting that to heat and then using that to heat the foods. A project working with a group in Georgia to try for Haiti, trying to see if we could dry peanuts and see how that works. So as a drying product, we think it could be used for a small like heater if it's like in very low kind of square footage location. Of course, you could always do the thermal to electric generation for very low power required devices, but we know we're not optimized for that. But if you need to do a quick cell phone charge or something, those kinds of things, we've demonstrated some of those elements within the labs. Currently working on it as possible with disaster preparedness, perhaps working with the military on some things. And so this might be an option for some of their work. So those are just some of the things that we're working through and submitting some additional humanitarian-based grants. And hopefully we'll start to see these populating in those regions, hopefully really serving a need that's there.
One that has come up that's gotten some discussion is PV direct to an induction stove. And I'm just wondering if is that something you guys are looking into? Because I'm thinking this has to be steel or iron, right? Where it could be maybe upside down onto an induction cooker to heat it up.
We want to do quick tests and consistent tests. We are using like a hot plate to do the test, which is simulate as though you're heating it with the sun. So we've already demonstrated that we could charge that way. We just want to like what would need to be the capacity delivered from the PV to be able to charge it in. How long would it have to be something that's continual for several hours, and then when you're ready, you flip it up and use it, or can it just will it have enough power to just charge it in that same 2-hour window that really good sunlight gives? And so it just and that'll be we'll do some tests in the workflow for the end user in terms of at what points they cook, and we test a lot in terms of what foods they cook in the different areas that we go into. So we try to make sure it's optimized to cook the food that you prefer for those different cultural reasons. So we make sure that we can cook those and try to measure the time. So we do a lot of reporting out because we work with a lot of humanitarian. The grants, they want to see what's the outcome of the day, what data outcomes you're getting, what information, which has been good for us because we're able to then demonstrate the efficacy of the device. But I said, if we're able to cook this at this point, this much, and it took this long to prepare, and it was able to serve X number of people sets. And then we'll be moving into more of a product certification stage, just to make sure it gets certified as a reliable product. So we're planning to submit this for within the U.S. as well as in the international markets through their certification.
Are you familiar with the Solar Cookers International's PEP test, Alan Bigelow?
Yes, I had looked at some of those as we've been going through what we can do to have as a standardized way that we've tested. Because we test the efficacy using like the water board test. So some of those typical tests. But we want to also test them on structural and other dynamics that will be important, or factors that will be important to the product overall release as we try to scale.
The one challenge Alan mentioned, because they're still working on how to actually test not so traditional, like the box cookers. Easy man. Once you get that, you've got it's a sticker they put on your product. So well, this is fantastic. I'm just thinking of this, and I'm hoping you can find something that does it a little more automatically, because it can be a real chore. But boy, those are dangerous. but you need a little danger to get the heat going, right? You know. So.
Yeah, and so we have a shield that we put over. So after the user has been finished using the parabolic, that we have a cover because we don't want it to be turned toward your home. Engineers and designers, we need to probably make sure that we can do some other things, and maybe the idea we would discuss building our own parabolic that might be collapsible, and we would talk to one designer where it might be something like a box, and you pull it out, it opens up, and even the bracket pops up, and we can put the bucket on that. So we've been looking at it, so it might be a, you know, like a few meters box that you can carry, not too heavy, probably within a little bit over to 20 pounds or something. That this carry that we can be able to pop it.
Well, how about you personally? You're committed to this project and the future of it. You're going to hang in there for that, right?
Yes. We all plan to see it through, because we tackled it. We started from really wanting to address a need and not really even thinking about a company. I mean, the ICOR and the opportunity to be able to how can we spread and transfer technology was more so the emphasis of the company as opposed to can we find a company to sell a product. And so I think the idea of kind of solving this global cooking crisis, that's the way that it's framed for our organization, the global cooking crisis and limited access for low resource communities with access to cooking alternatives. And so, you know, we're involved and we want to see it successful. And our biggest goal is to make sure that where we're selling the product, we're also doing other developmental things in those communities. And that's one of the reasons that we want to, if we're selling these in Kenya, we want to be manufacturing, building in Kenya and providing jobs to individuals working in Kenya. If we're selling in India, likewise, and if we're able to, we do look at as a potential opportunity, maybe sell them in the U.S. as more recreational cabinet for people that want it. You don't want to heat your house in the summer. You don't want your AC running all the time and not using your stove.
Well, what I'm picturing, and this is, I try not to interject ideas, but I can't help but looking at the smaller models and thinking if they're maybe an inch or two smaller, a little shorter, it would fit on the Simplicity. Simplicity is not a real high power, it's about 800 millimeters, so it's not quite a meter. But I'm thinking maybe even a little smaller, and it might actually be, you might actually be able to have something like that.
You know, I meant to ask what the insulation, is this, what kind of insulation is this?
This is pyrogel, if I'm not mistaken. We just started to move to this because it's a little bit less expensive than the material that we used to use. And so we can cut it in these little shapes and then stuff it and put a hole in this to provide insulation, the bucket, and also stuff it inside of the lid. And so we're exploring ways to reduce production costs, and so these are just ways that we're exploring to still get the same efficacy in terms of insulation. And we're testing it to see, and this is what this was happening, testing to see how effective it was compared to. I'm trying to remember what we used to use, but it was expensive and very dusty.
Okay. And it's got to take 600 Fahrenheit. What's that, 300 Celsius? What is it?
Yeah, about 350, 300,
Yeah. So that's, it's got to be tough. Well, thank you so much.